Let's find an inverse function and then graph it, and we're actually going to do this twice in this section. So here, this is a function, 3x minus 1. That's a linear equation. What we're going to do is we're going to find the inverse, and this is the notation that we use for that. All right, so I do want you to use this notation. And here's how we're going to do it. What you do with a function like this, the first step is you make that y. Your second step is you switch the two variables. In an inverse function, all of the domain becomes the range, and all of the range becomes the domain. So that means x will be equal to 3y minus 1. Now, in the continuing steps, your basic job is to get it back to where y is by itself, and solve for y is basically where you go. So to solve for y, I'm going to add 1 to both sides. And it looks like here I'm going to need to divide by 3. So now I have x plus 1 over 3 is equal to y. That is usually better written with the 3 underneath each thing. So what I'm going to do is, and I actually would prefer to have the y on this side, so I'm going to switch it there. Y is equal to 3 goes under the x, and 3 goes under the 1. Now, this works well in as slope-intercept form because that's 1/3 x plus the y-intercept, 1/3. The last thing, though, is we have to use this notation. So the sixth thing here is to do that the function -1 x, the inverse function, is equal to x over 3 plus 1 over 3. That is the inverse function of this original function up here. Now we're going to graph this in a couple moments, but what will happen, we'll see that there is a reversal sort of, and based on the line of y equals x. Okay? However, there's another thing we have to do here, and that's to verify that this is really true. And what we do here is that we would take the function and we would compose them. So we would do that the function of x is composed of the inverse. And we're actually going to do it twice. Where what we're going to do here is we're going to do the function minus 1 of the function of x. So now here, we're going to take one of these. In this case, we're going to take this one and put it inside here. So the function of x, well, actually all I really need to do is take this and put it in here. I'll write it as, I think I'm just going to write the equals here, 3x to the third plus 1/3 minus 1. So what I get is the 3 cancels out with that. The 3 becomes plus 1 and minus 1. So the function minus 1, whoops, function, I had it right here, f minus 1 x equals that. And what we get is just x by itself. If we get x by itself in both of these, that verifies that this is an inverse function. So now I'm going to do the same thing here. I'm going to use this one, x over 3 plus 1 over 3. I have to take the original function and I have to put it inside here. And let's see if it also equals x. So I'm going to have 3x minus 1 over 3 plus 1 over 3. Okay? Well, in this case, these 3's I can add together, 3x, and because this is all over 3, minus 1 plus 1. Well, those cancel out, and the 3's cancel out, and this equals x. Because both of these equal x, they are a function, or this verifies that this is indeed the inverse of this function. Now, this is part 1 here. There is a part 2, where we're going to do it with a different function. And in this case, it's going to be the function of x cubed minus 1. Okay. So in order to find the inverse of that, we're going to do those same steps, where the first step is to make that y. The second step is to reverse the two variables. And now we solve for the y. So what we do here, solving for y, would be adding 1 to both sides. Now we'll take the cube root, fourth step, cube root here, and the cube root on this side will give us our y, no problem. Switch it back over, but the y has to be written as f minus 1 of x, cube root of x plus 1. And to verify it, we could put them inside each other. That's an important part of it. I'll warn you right now, you will see that almost certainly. I have to verify it. So I'm going to do the function, this function composed of the inverse function. So here I would have x cubed minus 1, but that'll get replaced. Cube root of x plus 1 cubed minus 1. So the cube and the cube root and the cube cancel itself, so we get x plus 1 minus 1, we get our x. When we do it over again, and we do the f minus 1 and the x, f of x here, we're going to do the cube root, and now I'm going to put x cubed minus 1, and then I'm going to do, let's see, it's plus 1. So I have to use this, and I have to put x cubed minus 1 in that place. So now, I don't even need the parentheses. Okay, how do I have that one here? Minus 1, I think I forgot a minus 1 and a plus 1 here. Aha, I am putting that one in here, I need to rewrite it, because I have the cube root, and I have this being replaced by x cubed minus 1, and then I have this plus 1. Well, the parentheses aren't needed anymore right now because there's no multiplying. So I have cube root of x cubed minus 1 plus 1. Those go away, and actually the cubes go away, so I get x. So now that verifies that these two that these are indeed the inverses of each other. The next step to this is to graph them. So what I'm going to do, and this will be the last part of this, so let's graph first, and I'll call this sort of part 3 here. I want you to see how these look graphed. So first, the function of x equals 3x minus 1. We now know from that other work that the correct inverse function of that, find it on this page, was, I'm going to do it as 1/3 x plus 1/3 because that gives me a slope. That's pretty easy to work with. Let's draw up here and here. So this one, we start at -1 for the y value, that's our y-intercept, and a slope of 3 and 1. So this one I will call f of x. You don't have to write out the whole thing, we'll just call it f of x. This one's at approximately 1/3. So I go half and about 1/3, and then I go slope of 1 and over 3, 1 and over 3, 1 and over 3. So it looks like we're going this way, and we'll call that one -1, or the inverse. So now what we've done here is we've graphed these two, and what you want to notice is that if we do the line like this, that's the parent function of all linear equations, y equals x. Notice that these two lines flip over that line. So this is a reflection. The inverse is actually a reflection of the original one. Now let's do that with the other one. And this will be the last thing for this, that the function of x is x cubed minus 1. The inverse function is the cube root of x plus 1. And here in this, you either want to do an xy table or you want to do it on a graphing calculator. Well, I set this up here with a couple of, a little bit of an xy table. So f of x and y, I could do a couple of points like 0 and -1 and 2 and 7. And that gives me a starting point because I know this is a cubit. 0 and -1 is here, about there. 2 and 2, 1, 2, 3, 4, 5, 6, 7. Oops, the line should have been straighter, sorry about that. Because it's a cubic, I know it's going to look like this. So what's happening is it's this basic curve that would have gone up through 0 in that way, but now it's just been moved down 1. So if I do 1, negative 1, so that's going to be at negative 1 and negative 2, and I'm going to go up like this. That's the basic one, f of x. For this one now, if I do the function negative 1x and y, I got a couple of values. Negative 1 is 0 and 7 is 2. So at negative 1 we're at 0, and then at 2, 4, 6, 7 we're at 2. Notice it's nothing more than the reverse. 0 and negative 1 reversed, 2 and 7 reversed, because the inverse function has the domain, or the x values, becoming the y values, or becoming the range, and vice versa. So it's almost like we're doing it like this. Ooh, now that's interesting. And if I go back to this x equals y line, or y equals x line, they are indeed they're switched, they're reflected over that line. And that's the key graphing point about these, is you graph one and you use the y equals x line, you can do the inverse graphically by each point, each matching point reflecting over that. Even with a curved one, you can find that they're each matching points, and they have a point where they'll meet on these curved ones. So this section, or what we've seen here now, is the steps to make an inverse function and then to verify it, even when you have to deal with something like a cube root or a square root, and then being able to graph them graphically with a graphing calculator, or even picking a few points and reversing the domain and range, and or using the y equals x line as a reflection line. And that is the section on inverse functions.